Hello guys, welcome to the Techogenius Academy. So today we are here to discuss the next video of Linux system programming. So earlier in the first video what we have discussed is pipe and the name pipe, which is nothing but a FIFO. So that is a inter-process communication. So now we will discuss the message queues. So what message queues are actually? So it allows the process to exchange the data in the form of messages. Whatever the functions involved in the message queues. One is message get. So it is useful for creating the opening of the message queue. Message send will helpful for sending the message in the message queue. Message receive is useful for receiving the message, and the message CTL is useful for doing some control operations on the message queue. IPCS-Q is a command to display the message on that message queue, and the IPCRM-Q at that ID is useful for deleting the message queue. Okay, so we will just go to the terminal. So we will write the message queue program to demonstrate how messages are we are sending and receiving through the message queue. Okay, vi message underscore send dot c. Okay, so before that I just want to show you the prototype. Yeah, so message get. So what are the arguments? So first will be your key and second will be your flag. This key will be same as we will use in another program or a process. Okay, so if we'll go to the main page of message send. Okay, yeah, so these are the message queue operations. So you can see that MSG SND message send and the message receive. So here we need to take care of few things. If you can see here, the message p argument is a pointer to a caller defined structure of the following general form. So now in this what actually it is. So the message p so it's a structure, so in which there are two types, m type and the there is an array of that string, so which we will pass in a runtime. So in that the message type should be greater than 0. Why? Because if message type is 0, then the first message in the queue is read. Just suppose there'll be so many message. So if you want to read the latest message what you have sent, if you have mentioned the argument that the message type is 0, then it will read the first message from that queue only. And if the message type is less than 0, then the first message in the queue with the lowest type less than or equal to the absolute value of the message type will be read. So we need to keep this message p will message type will be greater than 0. We need to keep it as greater than 0, some 1 2 and all. So you can see here, then the first message in the queue with the lowest type less than or equal to the absolute value will message type will be read. Okay, so now we will go to the program. So now what we will do, we will include the header file which we have used in our earlier program. So we have included all the header files into that, so we will just include this. Okay, after that the structure, which I have showed you just now, message buff. There'll be long m type. I can mention as a comment, message type will always be greater than 0. Character, some data, some array of int main. So we will use the runtime arguments argc, because we will pass the count, the m type, and the array and at runtime. Argv. So first will be the id, int id, and your structure variable, which we will use for message type and the string which we will pass. V id equals to, it will return the id, message get 3, some, this will be the flag, which will be the create, or and we can pass the mode permissions, the error message, now the type, a to I arg v of 1 strcpy v dot data arg v of 2 printf id equals to percentage d slash n id message send, your id, your structure variable, size of that string which we are passing, plus 1 comma the 0. So that's it. So flag, we will make it as a 0. We'll close this. cc message send dot c hyphen o message send. Oh, oops, error is there. Okay. Yep. Yeah, so our executable is created. So now we will write the another program for receiving the message. Hash include header.h struct message buff long m type character data of some 20 bytes int main int id id equals to the same thing. We'll write the structure also, the variable id equals to message get 3 comma ipc grade yep pre-error message get printf before receiving the message receive id address of v comma 20 the size 2 comma 0 printf data equals to percentage s slash n comma v dot data. So now what is this do? So this is the question for you. Okay, so you have to find out from the message send call. Okay, so our program is almost finished. cc message receive dot c hyphen o message underscore receive. Yep, that's it. So now we'll open another terminal. Just to have you a better understanding of this. Yep. Message send. Okay, 1 second. Yeah, message send. We have not passed the argument, so that's why. Just 1 second. Message send, the type and the Deku Genius success IPCS hyphen Q. One message is there in the queue. Go to the next terminal. Message CD Linux IPC message receive. Message get before receiving the message data is Genius. We have sent it here. So now just check IPCRM. Okay, so IP we will just check the IPCS hyphen Q. There is no message, so message is already successfully sent it to that. So now what we will do, so this message receive program is waiting for message from the message queue, so we will send it here. Hey, see, that message is received. So in this way you can communicate between two processes through this inter-process communication. So actually this is the slowest IPC. Why? because when the two process has to communicate in the message queues, so kernel make a linked list. It will send the data to it, and the kernel has to do lots of work. So that's why it's a slowest IPC. So to overcome this, there'll be another message queue, which is nothing but a shared memory. So in shared memory, it allows the two or more processes to share the same region of the physical memory. One process copies the data into the shared memory. At the same time, the data is available to all other processes sharing the same segment. So this provides the fastest IPC. The function involved in the shared memory is the SHM get, the SHM attach, the SHM detach for detaching, AT for attached, get for creating as well as opening the shared memory segment, and it will return the identifier. SHM CTL is used for deleting the shared memory segment. So this segment will be destroyed only after all the current attached process have detached. Only one process needs to perform this step. So now there will be two process which will access the same shared resource. So that part is nothing but a critical section of code, a part of program which we are trying to access the shared resource. So now, what is deadlock situation? When two or more process wants to acquire the other resource or the same resource, and that is not available, and for that reason it will block. To overcome this, what will be the solution? Just mention the comments. I will get back to you on this. So now, what we will do? We will just write the program to make you better understanding of the shared memory. So now we will write the code of SHM get, where we are using this, and the SHM AT for attaching the shared memory segment. So SHM dot C, yeah, hash include, I'm including the same header. So this header file I have shown you in the first video of this Linux system programming. So if you don't know about this, what are the header files included in this header.h, so please go and watch my previous first topic, which where we have discussed pipe and named pipe. Int main, int id, comma, I'll just create, I'll just declare some pointer. This I have used id, okay, shm get key size and the permissions, create. So you can see this definition and all, and man shm get, yeah, first will be the key size and the flag, okay, and will return the identifier. Error shm get printf id shmat id null. We are just passing this argument as 0 because we don't because we are sending the SHM address, because the second arguments which we are passing is the shared memory address. I can show you SHM80. Oh, yep. So SHM address. So this I'm passing as 0. So if SHM address is null, the system chooses a suitable address at which to attach the segment. Okay. And the flag also I'm not using anything, so that's why I'm just keeping it as a 0. Printf, enter the string, scanf, percentage %s, comma, the string. Great. ccshm.c hyphen o shm underscore 1. Oops. Once again, please and declare. Oh. Yeah. Yeah. So it's done. So now what we will do, we will just copy this file to another shared memory file, and here I will print the string data percentages slash n comma p. Great. So to do this, I'll just open another terminal. Great. So shm1, enter the string. Here ccshm 2.c hyphen o shm2 shm2. Oh, sorry, I've not entered the string. Rajat. So Rajat, we are displaying. 1 second, I've done some mistake. Okay. Oh, sorry. So I wrote it here while when. Okay, I missed that. So that's why it's printing again and again, and on the same resource. Yep. So what we can do here, I can block this. But this will not come here. So every time we need to run this. Yep. So now here I'm sending the data, anything, and if you can see here, I'm receiving. Okay, so in this way we can the two process we can access the same resource. Okay, so this is the fastest IPC, and this is all about the interprocess communication. So what we have covered is pipe, named pipe, message queues, and the shared memory. So now I will discuss the semaphore, mutex, threads, signals, how we can create a fog system call, uh, what is hard link, soft link. So basically, what are the system calls we are using in the system programming Linux. So we'll discuss in the next session. So for that, like, please don't forget to like, share, and subscribe if you like this video. And if you want any particular topic, just drop in the comments. We will provide you as soon as possible. Thank you so much.